the recording for the exam paper walkthrough for GCSE Combined Science Trilogy Foundation Chemistry Paper 1. All substances are made of atoms. Figure 1 represents a beryllium atom. What is the number of protons and the number of neutrons in a beryllium atom? In a beryllium, there are 1, 2, 3, 4 protons and 1, 2, 3, 4, 5 neutrons. How did I know that the protons were the plus signs? Well, the protons have a positive charge, so they are often represented with a plus sign. 4 protons and 1, 2, 3, 4, 5 neutrons. How would I know that beryllium had 4 protons and 5 neutrons without this image? If I look on my periodic table, which is provided for you in your exam, beryllium, Be, has the atomic number of 4 and the mass number of 9. From that we can work out the PEN, and it's 4, 4, 5. Figure 2 represents a beryllium ion. What is the relative charge on a beryllium ion? Beryllium ion, well, an ion is an atom that has gained or lost an electron, and when we form ions, metals become positive, metals are positive, and non-metals become negative. So metals are positive, non-metals are negative. There's the mapnan that I have in my brain every time I'm thinking about ions. Now, since it's a positive ion, we can discount the 0 because beryllium ion will have a charge. Then what we look at is which group beryllium is in. Beryllium is in group 2, so therefore it forms a plus 2 ion because it loses the 2 electrons that it had in its outer shell. Figure 3 shows arrangements of atoms in the 3 states of matter. What state of matter is represented by state C? Well, this is solid, liquid, gas. What is the name of the process when state B changes into A? B to A, from liquid to solid, it's freezing. How can state B changed into state C? When you add heat, we can boil it. So add heat and we can boil it. Experimental evidence led to the scientific model of the atom changing over time. Figure 4 shows the 3 models of the atom. What is the order of the development of the model of the atom? Without knowing any science, when I look at images and I say, oh, how does something develop? Well, something develops to become more complicated. So we know that the tiny spheres model, that's the first one, so it could only be these 2, so we discount these 2. And then the next more complex one is the plum pudding model, so it's this, and so we discount this, and this is our answer. And finally, the nuclear model is even more complicated than the plum pudding model. Complete the sentence below. Choose the answer from the box. The existence of neutrons were discovered by Chadwick. A student investigated the temperature change when magnesium was added to zinc sulfate solution. So here's a strip of magnesium added to a solution of zinc sulfate. With which piece of equipment is labeled X? Well, they're asking to measure temperature change, therefore it's a thermometer. Which piece of equipment is the best to use to measure volumes of a solution? Remember, volume is how much space it takes up, and that is measured using a measuring cylinder. And it sort of looks like this. So there we go. And it has lines on it to see the volume when you put the liquid in. The student added 1.0 grams of magnesium to 50 centimeter cubed of zinc sulfate solution and measured the temperature increase. The student repeated the experiment 2 more times. The student added 1.0 grams of magnesium, 50 centimeters cubed of zinc sulfate solution, and measured the temperature increase. The student repeated the experiments 2 more times. And then they calculated the mean. It's asking us to calculate the mean. So mean equals 7.6 plus 7.3 plus 7.6. You have to add all the 3 numbers up and then divide by how many numbers there are, which are 3 numbers. And when you do that, you get an answer of 7.5. Remember to write your answer on the answer line, which is here. The student then added 1.2 grams of magnesium to 50 centimeters cubed of zinc sulfate solution. The temperature increased by 9 degrees. Calculate the temperature increase when the student added 0.4 grams of magnesium to 50 centimeters cubed of zinc sulfate solution. Simple. So it's saying this is the ratio when it's 1.2 grams, the temperature changes 9 degrees Celsius. So what will it be when it's 0.4 grams? Well, how much smaller is 0.4 compared to 1.2? What would you have to divide 1.2 by to get to 0.4? You have to divide it by 3. Therefore, the temperature change would be 3 times smaller, which would be 3 degrees Celsius. 9 divided by 3 is obviously 3. What is the name given to the reaction which causes the temperature to increase? So, in an endothermic reaction, energy goes in. In an exothermic reaction, the energy goes out. And thermal decomposition is an example of an endothermic reaction. So, what type of reaction is this when the temperature increases? Well, you have to imagine what happens when the energy goes out. The energy goes out to the surroundings get hotter, so that when the temperature increases, it's an exothermic reaction. Then the student repeated the experiment with 1.2 grams of copper and 50 centimeters cubed of zinc sulfate solution. The temperature did not increase. This is and you have to give the reason why. The temperature didn't increase because there was no reaction. No reaction of copper with zinc sulfate. Okay, and why is there no reaction? This is, if it was an explain question, you would write because zinc, copper even, is less reactive than zinc. Next, structure and bonding is used to explain the properties of compounds. Metal atoms react with non-metal atoms to form ions. Which group of elements does not form ions? This is asking which group of elements do not react in this particular way. Well, is it alkali metals? No, alkali metals do react to form ions. Are they halogens? Halogens even. They do react because remember, chlorine and fluorine, they can form negative ions. However, noble gases are unreactive, so they won't form ions. Potassium reacts with chlorine to produce potassium chloride. Figure 6 shows that what happens to the electrons in the outer shell when potassium atoms react with the chlorine atom. The dots, which is represented by zeros and crosses, represent electrons. Describe what happens to the potassium atom. A potassium atom reacts with the chlorine atom to produce potassium chloride. It gives you the pictorial representation. You just have to write what happens. But what happens is, this electron that the potassium has, it loses it, and it's gained by the chlorine, so that the potassium goes from being an atom into being a potassium ion, and chlorine goes from being an atom into a chlorine ion. How many electrons does each lose? Potassium loses one, chlorine gains one. So we say potassium loses one electron to make an ion. Chlorine gains one electron to make an ion. Ion. There we go. Now, this is an interesting marking point. It says the losing and the gaining, those are 1 mark each. Reference to 1 electron, that's another mark. So there's 1, 2, 3 marks. And then the making of the ion is the other mark. So that's how you get the 4 marks. In solid ionic compounds, oppositely charged ions attract to form a giant structure. Which structure represents the arrangement of ions in a solid potassium chloride? Here's interesting. For a ionic compound, these giant structures are formed by positive, negative, but it's in every direction. If this is positive, the next one will be negative. positive, negative, and this will be a positive, this will be a negative, but it will be a 3D structure. So which represents that diagram best? This one here. Okay. Normal metal atoms share electrons to form covalent bonds. Water is a covalent molecule. Table 2 shows the number of electrons in the outer shells of the hydrogen atoms and the oxygen atoms. Figure 7 shows part of the dot and cross diagram of a water molecule. Complete the dot and cross diagram. Remember, covalent molecules have shells that overlap to share electrons. Hydrogen has 1 electron on its outer shell and oxygen has 6. They both want full outer shells. This wants 2 and oxygen wants 8. Well, what can oxygen do to get 8 electrons in its outer shell? It can add 2 more. And it does that by sharing hydrogen's electron. This causes a bond. So if you look here, this oxygen electron is shared with hydrogen, and hydrogen shares its electron with oxygen. Therefore, now this hydrogen has 2 electrons in its outer shell. We want to make the same thing happen for hydrogen on the right. Oxygen shares 1 electron and hydrogen shares another. Now remember, they have drawn it on these overlapping lines. However, we can draw it in the middle of those overlaps, in the middle of that Venn diagram, if you will. Now, both hydrogens are satisfied. What about oxygen? Does it have 8 electrons? Well, it had 6 electrons of its own and 2 needed to be added. Out of the 6 electrons that oxygen has, these 2 are already drawn. Now we need to draw another 4. 1, 2, 3, 4. Now we can go around and count how many electrons oxygen has. 1, 2, 3, 4, 5, 6, and then the 2 that it's added, 7, 8. Silica has a giant covalent structure. Figure 8 represents the structure of silica. Determine the ratio of silicon atoms to oxygen atoms in silica. This is quite simple. When you are determining the ratio of anything, you count the number of atoms that you see. You see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 oxygens, and 1, 2, 3, 4, 5, 6 silicons using the key. However, when you do ratios, you have to do it in the smallest sort of ratio possible. And so you have to simplify it. Simplifying this gives you 1 to 2. Polymers have very large molecules. Figure 9 represents the structure of a polymer. Polymer 1 and polymer 2. What holds polymer 1, molecule 1 and polymer molecule 2 together in a polymer? Let's see. Had it been covalent bonds, it would have been represented by a stick. So it's not a covalent bond. Had it been weak electrostatic attraction between ions, these polymer molecules will have been charged particles or charged molecules, but they're not. Instead, it's weak intermolecular forces. That's why they're easy to rip apart. Sometimes weak intermolecular forces are drawn as these tiny dashes. Figure 10 shows the melting point of a polymer as the length of the molecule increases. Describe the trend shown in figure 10. Okay, so we always start with the x-axis. We say as the length of polymer molecule increases, we say melting point increases. Okay, then what happens here? What happens is that for large lengths of polymer molecules, the melting point, it hits a plateau, or we say it doesn't increase anymore. Another way of saying it, the melting point levels off as the length increases. Now, if there was numbers on the graph, we might have been able to use numbers to justify when it levels off. Question 4. Copper bromide solution is electrolyzed using inert electrodes. Figure 4 shows the apparatus. Positive electrode, negative electrode, power supply between those 2 points. And what happens is the positive electrode attracts the negative ions and the negative electrodes attract the positive ions. Which particles carry the charge through the metal wire? So we know from physics and from chemistry for for electrical current to work, to flow, or charge to flow, we need delocalized electrons in a wire. But that's not the case for the electrolyte. The electrolyte has ions that move. These are the 4 ions in copper bromide solution. Copper 2+, bromine minus, hydrogen plus, and hydroxide minus. 2 of these ions are formed when a water molecule breaks down. The symbol equation when a water molecule breaks down is H plus OH minus. Complete the word equation for the breakdown of a water molecule. Okay, so water turns into hydrogen ion. So hydrogen ion, and they're actually asking us to name what this is. It's a hydroxide ion. Hydrogen and oxygen is a hydroxide. Copper ions and bromide ions carry the electrical charge through the solution. The formula of copper ion is Cu2+. The formula of bromide ion is Br-. What is the formula of copper bromide? This is simply, can you do the ratios? Cu2+, Br-. What combination of Cu and Br will give you an overall charge of 0? Well, if you have 1 Cu, we'll need 2 Brs, okay, to give you the overall charge of 0. So how do we write that? We write it as Cu, Br, and then little 2. Next, explain why copper ions move to the negative electrode. Copper ions are obviously positively charged. And charged, and they are attracted because of electrostatic attraction, attracted to the negative electrodes. I'm going to say negative side just to put that picture in your brain. Complete the sentence. Choose the answer from the box. At the negative electrode, copper metal is produced when the copper ions are, well, what happens to the copper ions? Copper ions, Cu2+, at the negative electrode become Cu. What changes? Well, this has a charge and this doesn't, so copper is discharged. The charge of it is taken away from it. What happens to the mass of the negative electrode during electrolysis? If copper forms on it, the mass will increase. There are 4 ions in copper bromide solution. Well, Cu2+, Br-, H+, and OH-. What is produced at the positive electrode when the copper bromide solution is electrolyzed? So at the positive electrode, the negative ion goes to the positive electrode, and therefore bromine is produced. Question 5. This question happens to be about the extraction of metals. Remember, in the previous question we looked at electrolysis, and electrolysis is a good way to extract metals. Here we're looking at electrolysis again. Aluminium is extracted from a molten mixture of aluminium oxide and cryolite using electrolysis. Figure 12 shows the electrolysis cell. Here's the molten mixture, and then the aluminium forms at the bottom. Complete the sentence. The extraction of aluminium is expensive because the process uses large amounts of energy. Now, why does this process use large amounts of energy? Because it is having to supply large voltages between the electrodes. Oxygen is produced at the positive carbon electrodes. The oxygen reacts with the carbon electrodes. Which gas is produced when oxygen reacts with the positive carbon electrodes? Carbon plus oxygen, CO2. Of course, it's carbon dioxide. Titanium is extracted from titanium chloride by reacting titanium chloride with sodium. So that's how to extract titanium. So just why the reaction is carried out in an inert atmosphere. Inert means does not react. Why does the atmosphere or the gases around this reaction have to be inert? Because sodium reacts with oxygen in the air, and if oxygen is removed and replaced with another gas, then sodium won't react. Complete the sentence. The gas used for the inner atmosphere obviously is argon. Hydrogen is extremely flammable, can't use that, and chlorine gas is toxic, so you can't use that. And argon is part of the noble gas group. Balance the equation for the reaction. TiCl4, which is titanium chloride with 4 chlorine atoms obviously, plus 4Na makes Ti and NaCl. To balance any equation, I start off by putting a dotted line down the middle. Then on my dotted line I write down all the elements that are involved. Titanium is involved, chlorine is involved, sodium is involved, and those are the 3. Then I go around and count up how many there's on the left and the right hand side. On the left hand side currently there's 1 titanium, 4 chlorines and 4 sodiums. On the right hand side there are 1 titaniums, 1 chlorines and 1 sodium. I want these 2 things to become 4 and 4. If that is happening, then we've completed our balancing. How do I make it 4? Well, if you look on the right hand side, they've left a gap for us, and if we add a 4 to the front of it, which means there are 4 molecules of NaCl, 4 molecules of sodium chloride, then 4 times Na is 4 and 4 times Cl is 4, and then we've finished our question. Copper is extracted from copper oxide by reacting copper oxide with carbon. Here's a crucible and a mixture of copper oxide and carbon, and heat is applied from the bottom. The equation is copper oxide plus carbon makes copper and carbon dioxide. In an experiment, 15.9 grams of copper oxide and 1.2 grams of carbon reacted. 12.7 grams of copper was produced in the reaction. Calculate the mass of the carbon dioxide produced in this experiment. So all we have to do is remember that 15.9 plus 1.2 gives 12.7 plus something, and that something is what we want to find out. Using our calculator, we do 15.9 plus 1.2, which is 17.1, is equal to 12.7 plus something. That something is 17.1 minus 12.7, which happens to be 4.4 grams. Explain why the mass of the contents in the crucible changed during the experiment. That's the even more important bit. Why did the mass of the contents of the crucible change? Well, during the experiment, the carbon dioxide gas escapes. That's the first thing that we can say. Mass decreased because CO2 escapes. And of course, if they ask you how would you stop that, you'd say have a lid, only open it periodically. What happens to the copper oxide in this reaction? Give one reason for your answer. What happens in this reaction is copper oxide, CuO, becomes Cu. Well, what does it lose? It loses an oxygen, and that means copper oxide is reduced because it loses oxygen. This question is about carbon dioxide, it says. Carbon dioxide is soluble in water and forms an acidic solution. Which ion makes a solution acidic? Remember, acidic means we're measuring pH, okay? And pH of 1 and 2 makes it very acidic. That pH stands for per hydrogen. Therefore, we're talking about hydrogen ions. Name an indicator that could be used to test if the solution is acidic. By the way, before I move on, you can just write hydrogen ion and you'll get the mark. Name the indicator that could be used to test if a solution is acidic. Give the result for the test. Well, there are multiple indicators that you could use, but I would go for universal indicator. Okay, and that universal indicator will go red or yellow or orange if it's an acid, or you could use a blue litmus paper which will turn red in the presence of an acid, or you could use methyl orange which turns red in the presence of an acid. Figure 14 shows the mass of carbon dioxide that will dissolve in 1 decimeter cubed of water at different temperatures. You can see that when the temperature increases, the mass of the carbon dioxide in grams dissolved in 1 decimeter cubed of water decreases. How does the solubility of carbon dioxide change as the temperature of the water increases? When the temperature of the water increases, the solubility decreases, which means it's becoming less soluble in water. Carbon dioxide dissolves in water to form an acidic solution. How does the pH of the solution change as the temperature of the water increases? Remember, pH scale goes from 0 all the way to 7 when it's neutral, all the way to 14 when it's alkaline. It's acidic here and alkaline here. And what happens in our graph is, as the temperature increases, there's less and less carbon dioxide. So if there's less and less carbon dioxide, we say it goes from being really acidic to less acidic. If it goes from being really acidic to less acidic, what happens to the pH? The solution, the pH is increasing. Calcium carbonate reacts with hydrochloric acid to produce carbon dioxide. The equation for the reaction is given. Calcium carbonate, hydrochloric acid, calcium chloride, carbon dioxide, and then water. What they are asking you what X stands for. S stands for solid, AQ stands for aqueous, G stands for gas, therefore, and then H2O, water, must be a liquid. Now, in some scenarios, the water could be water vapor, in which case it's a gas. Here, it's a liquid. The student investigated the volume of carbon dioxide produced when different masses of calcium carbonate react with hydrochloric acid. And here are 4 different pieces of equipment given. It asks, describe the method they could use to do this. So, here is what we have to write. You have to say that you're going to, the independent variable, what you're going to change. We are going to change, well, the different masses of calcium carbonate. Independent variable is mass of calcium carbonate. How are we going to change it? We're going to measure it using a mass balance. Okay? And then what are we going to do to it? We're going to add, so we've got our independent variable. We're going to add calcium carbonate, which I'm going to write as CaCO3, into conical flask. That's not how you spell conical, is it? Conical flask. That's this. So we've used these 2 pieces of equipment. Then what would you do? Then you measure a specific volume of hydrochloric acid, which is HCl, using a measuring cylinder. And then you add it to the conical flask. add HCl to conical flask. And then what we have to do is use the gas syringe. We've used the three pieces of equipment. We need to use the fourth piece of equipment, which is cover, or immediately place the stopper. Why immediately? Before it starts reacting, basically. Immediately place the stopper. IMME. Place stopper and gas syringe. And what happens is the bubbles gas come into it and then fill up this gas syringe, and you measure volume of CO2. Okay, so this bit, measuring the volume of CO2, that's my dependent variable. Specific volume of HCl, that's my control variable. Look at that, I've used independent, dependent and control variables here. Now, one more thing is, how do we change it? We repeat, using different masses. Of calcium carbonate, CO3. There we go, and that's 6 marks in the bag. Question 7. Lithium hydroxide reacts with sulfuric acid to produce lithium sulfate. The equation of the reaction is LiOH plus H2SO4, Li2SO4, H2O, which is lithium hydroxide plus sulfuric acid makes lithium sulfate plus water. What type of reaction is this? Well, in this reaction, you have an acid, and here's an alkali. Acid plus alkali makes a salt plus water. This is a neutralization reaction. Next, calculate the relative formula mass of sulfuric acid. Quite simple. We have been given H2SO4, and we've already been given the masses of each of the elements. Simply, we have hydrogen, sulfur, and oxygen, and number of atoms and mass. So there's 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. And sulfur has a mass of 32, and oxygen has a mass of 16, sulfur has a mass of 32, and hydrogen has a mass of 1. To find the masses of this all together, you have to do 2 times 1, which is 2, plus 1 times 32, which is 32, plus 4 times 16, which is 64. Now, adding all 3 of these numbers together will get you 98. Am I right? 98, yeah. And that is how you find the mass of sulfuric acid. You use the number of atoms and you use the mass provided, but you times the number of atoms by the mass to find the total molecular, the relative formula. Calculate the percentage by mass of oxygen in lithium sulfate. Relative mass of oxygen is given, relative formula mass of lithium sulfate is given. Give your answer to 2 significant figures. It's good that the relative formula mass of lithium sulfate is given, otherwise we would have had to do what we did in the previous question, written down how many lithiums and sulfurs and oxygen there are and calculated the mass of it that way. But instead we've been given that. We haven't been given what the actual mass of oxygen in lithium sulfate is. We know relative atomic mass of oxygen is 16. However, for oxygen, there are 4 oxygens in a lithium sulfate. So you times 4 by 16 to get the mass of oxygen, which is 64. Now, 64 out of 110. We just have to find what 64 out of 110 is as a percentage. To do percentages, you take whatever number you're finding and whatever number you're finding it out of, and then the 110 goes at the bottom, 64 goes at the top, then you times it by 100 because it's a percentage. When you put these into a calculator, 64 divided by 110 times by 100 happens to be 58.18%. The issue now is we need to give it to two significant figures. The first two significant figures are 5 and 8. Then we actually have to look at what's after the decimal. Because it's less than 5, we round down and we end up with 58% as our answer. A solution of lithium sulfate contains 0.3 grams of lithium sulfate in 25 centimeters cubed. Okay, a solution of lithium sulfate contains 0.3 grams of lithium sulfate in 25 centimeters cubed. Calculate the concentration of lithium sulfate. To find concentration, you have to give it in grams per decimeters cubed. Simply put, 0.3 divided by however many decimeters cubed there are. However, the volume is given in centimeters cubed. This is the only subject where you have to convert centimeters cubed into decimeters cubed. And to do that, you divide by 1,000. Dividing by 1,000 gives you 0.025 decimeters cubed. Then you do 0.3 grams divided by 0.025 decimeters cubed to get an answer of 0.0 to get an answer of 12 grams per decimeters cubed. Okay, now remember the equation that I'm using is concentration is equal to mass over volume. Write 12 on the answer line and we're done. Well done for getting to the end.